Okay, so today we're going to talk about group theory problem 4 from the August 2016 qual. So we want to prove the following version of the Chinese remainder theorem. It says let m and n be two integers with the GCD of 1, and for every a and b in the integers, we want to show that there exists some z such that z is equivalent to a mod n and that z is equivalent to b mod m. So the proof goes like this. We want to let z1 and z2 be integers and consider the system of congruence relations given by these two systems, where the first system is that z1 is equivalent to 1 mod n and that z1 is equivalent to 0 mod m. And the second system is that z2 is equivalent to 0 mod n and that z2 is equivalent to 1 mod m. And we want to note that the existence of such a z1 and z2 comes from Bezout's identity, which states that there exists an L and k that are integers such that n times k plus m times L is equal to 1, in particular the GCD of m and n. And hence we can say that m times L is equal to 1 plus nk prime, and n times k is equal to 1 plus m times L prime, where k prime is equal to negative k and L prime is equal to negative L. So if we let z1 be m times L and z2 be n times k, this gives us the intended result, because m times L is equal to 1 plus nk prime, which is 1 mod n, and then 0 mod m because it's m times L, so it's a multiple of m. And then similarly for z2, letting that equal nk, you can do the same thing and you get the same situation occurring. So now given any a and b and z, we can say that a times z1 is equivalent to a times 1, which is a mod n, and that a times z1 is equivalent to a times 0, which is 0 mod m. And similarly, b times z2 is equivalent to 0 mod n, and b times z2 is equivalent to b mod m. So then we just let z be a times z1 plus b times z2, and we get the intended result, because z is equivalent to a times z1 plus b times z2, which is equivalent to a plus 0 mod n, because a times z1 is a mod n, and b times z2 is 0 mod n. And similarly, z is equivalent to 0 plus b, which is b mod n. And so because this algorithm gives us an intended z, and this held for any a and b and z, we have the intended result. Okay.